Today the topic is remote 3D printing, and I'm going to show you my guide for installing OctoPrint on Linux step by step. I'm Leo and this is my channel, Leo Tech Lab. If you don't know it yet, take a look at the introduction video. Let's go! Okay, so in terms of requirements for this guide, you will need a computer with a Linux operating system connected to your network. I'm assuming it's your home network, and we're going to install OctoPrint on this computer. I tested this guide on Linux distribution Ubuntu version 22.10, okay? You will also need, obviously, a 3D printer, and you will also need a USB cable to connect the 3D printer to the Linux computer. It is highly advisable not to allow current to go through this USB cable, okay? So that it doesn't interfere with the 3D printer's electronics. To do this, you can either buy a USB adapter that blocks the flow of current. Okay, I'll leave a link to one of those in the description. Or you can take a little bit of isolation tape, so electrician tape, and cut just a little bit of it and cover the fourth pin on the right. When you're looking down in the front of the USB plug, the fourth pin on the right it's the 5-volt pin. Okay, so if you cover that pin and let the other 3 pins go through, it will only allow data to pass. Okay, and that's what we want. You will also need to have Docker with Docker Compose version 2 installed on your Linux computer. You can easily check if you have Docker Compose version 2 already installed. You just type docker space compose, and if the command works or reacts positively, you have Docker Compose version 2. If not, and if you are still using docker-compose, that's the version 1, the old version, okay? That will be discontinued shortly. So we're going to use Docker Compose version 2 in this guide. If you don't have Docker installed, or if you don't know how to install Docker on Linux, you can check out my new video on it's a basic introduction to Docker, and I have a full chapter dedicated to installing Docker on Linux step by step, okay? Finally, you will need some time and patience. Okay, so let's start our guide. So first we're going to connect the USB cable from our 3D printer to our Linux computer, okay? I've already done that. Don't forget to power up the printer, okay? Important point. Now let's validate the connection using the Linux terminal, okay? And basically we need to ensure that the device is detected and that the device driver for our printer controller is working properly. How do we do this? We use the lsusb command. So this command basically lists all the USB devices in our Linux computer, and around here we must have our printer, and mine is this one, the Kinhang Electronic CH340 serial converter. Okay, so it's using USB bus 3, and it's the device number 3 on that bus. Okay, how do I know this, and how can you know which is the correct device? Well, basically what I do is just unplug the USB cable, run lsusb, the line will be gone, and then I reconnect the USB cable, and then I run lsusb again, and the line pops up again. So that's how I know, and that's how you can know which device corresponds to your 3D printer, okay? But this is not all it takes for everything to be working properly, okay? Because we have the device connected and recognized by the operating system, but we still need to have the device driver loaded so that we can interact with the printer via our Linux operating system. Okay, so let's find out if we have a device driver connected to that device. For that, we're going to use the -T option in the ls-usb command, and we're going to go to bus 3 and device 3. So bus 3, device 3 is this line, and look at it, driver equals nothing. Okay, so it doesn't have the device driver loaded for this device. Okay, if you see the other lines, they all have drivers. Driver, we don't have it. Okay, so it's not working properly. Okay, this means that if I do an ls/dev, okay, so this is the devices directory, I should be looking at something like TTY USB 0 or TTY ACM 0. Okay, at least for my printer it's TTY USB 0. Okay, I'm running Marlin firmware on my printer, and I do think that several other 3D printers are the same, but yours could be different. Okay, but for my printer is TTY USB 0. And here we have the TTY devices, and it goes all the way from here. So this is in alphabetic order, and it goes down to here, TTY S9. So no TTY USB 0, okay? And no TTY, so the letters start here, no TTY ACM 0 either, okay? So this means that the device driver is not loaded. Okay, actually I can show you another way you can know if the device driver is loaded or not. We can use the LSHW, which stands for list all the hardware of the machine. This command should be run with administrative privileges, so I'm going to use the sudo command, which does just that, sudo lshw, and this I have to put my password for my current user, and this lists all the hardware in the machine. Okay, this is a really big list, so we have to filter it. So in order to filter it, I'm going to use a pipe grep, and I'm going to need so if I do a grep kinhang, which is the name of the device, it will list. Okay, it found it. So I do have a line in the middle of all of that information, but I do need a little bit of context, so I'm going to add the -b, stands for before, so I want 20 lines before the line that matches, and after I want 20 lines also. Okay, this will give us a little bit of context, and here it is. Okay, so this section here corresponds to our printer, and it is unclaimed. Okay, see that, unclaimed? Okay, this means no device driver. If you look down here, you don't have claimed. Oh, another way you can look at it is the configuration attribute. It doesn't have the driver. Okay, so up here you have configuration driver USB HID. Down here you have configuration driver equals hub. Over here, no driver. Okay, so this is another tip for you if you want to find out if your printer device driver is working or not. Okay, how do we solve this? So I've been exploring and scouring the internet looking for answers, and I found something. I found a forum post that found an answer for this. I will leave the link to that post in the description, okay, if you're curious about it. But long story short, it appears that this particular distribution, so Ubuntu, especially from version 22.4 onwards, I don't know if before the problem was present or not, but Ubuntu comes bundled with a package called BRL TTY, okay, which is a Braille package. I think it's a Braille display or something. It's a Braille device, okay, and it appears that this package conflicts with our 3D printer controller. We can simply remove the application and the problem goes away, okay, so that's exactly what we'll do. So we will need to have administrative privileges for this, so I'm going to do the sudo command, then apt, which is the package manager for Ubuntu, okay. Now package manager, I want to remove the package brltty, please, okay. And do you want to continue? Yes, I do. Capital Y, enter. It is removing the software and it's done. Okay, so now let's reboot our computer so that the device driver can be mounted on the device, and hopefully we will have the /dev/tty USB 0 file. Okay, don't forget, everything is files in Linux, and that will mean that the printer is up and running, okay, in terms of connectivity with our Linux machine. So I'll see you in a bit. I'm going to restart the computer and I'll be back. Okay, I'm back. Okay, so I've just rebooted the Linux computer, and let's go ahead and open our terminal and check if we have the device driver loaded this time. So ls/usb, just to make sure that the device is still in the same spot. So USB bus 3, device 3, okay. Now ls/usb -t, bus 3, device 3, and we have driver. Okay, we have a driver CH341, okay, so it must be compatible with this CH340, okay, perfect. So this means that if I now ls the dev directory, we should have the TTY, here it is, TTY USB 0. Okay, so this file means that the device driver is correctly loaded, and we can use this file to interact with our 3D printer. Perfect. Okay, oh, and by the way, we can check the LSHW to see that it is no longer unclaimed, remember? So pipe grep, I need context, so -b before 20 lines, after 20 lines, kin hang, which is the name of the device, kin hang something, my password, and here it is. Okay, so no more unclaimed text over here, and in the configuration attribute we now have the driver. See? Okay, so these are all different ways you can check if your printer is up and running in Linux. Okay, so we're good to go. This step is done, and I'll see you in a bit. Okay, now that we already connected successfully our printer to our computer, let's download the Docker image for OctoPrint. Okay, so first of all, let's open our browser and let's go to the OctoPrint website, which is www.octoprint.org. Here it is. Let's go down to the download section. Okay, and now let's find the distribution for Docker. So this is Octopi, Octo4A is for Android, no, Docker. Okay, There's also an official blah 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 blah. Please refer to its entry on Docker Hub. Okay, for more details on usage and configuration. Perfect. So if you remember my introduction video from Docker, or if you've seen it, or if you already know Docker, okay, Docker Hub is the main repository for Docker images. Okay, there are others, but this is the main one. So let's go there. And so this is Docker Hub, and we are already on the OctoPrint image page. Okay, so the name of the image is OctoPrint/OctoPrint, 10 million plus pulls, which stands for downloads in Docker language. And here is the pull command. So we're going to do a Docker pull and then the name of the image to download the image to our Docker instance in our computer, okay, in our local repository. Okay, so let's open up the terminal. Let's copy this. Actually, let's just check the images we have. Okay, so remember that Docker is an administrator command, so you need to have administrative privileges unless you've configured it otherwise, but I really don't recommend it. I do think that Docker is extremely powerful and should be used only with administrative privileges. So I'm going to sudo docker. Okay, remember sudo is the command that you use to execute a program with administrative privileges, and I'm going to ask him what are the images installed on my machine. And we only have one image, hello world. Okay, so we don't have the OctoPrint image, so let's download it. I'm going to paste the command. Oops, we need to prefix that with sudo. So sudo docker pull OctoPrint/OctoPrint. Okay, go and fetch that image. Okay, so it's downloading the image. This is quite a big image. I think it's like 1 gig in size, 1 gigabyte. Okay, and when he finishes downloading the image chunks, okay, the images are downloaded in chunks, and then he extracts them like an unzip, and he extracts all of it and puts it all together to form the final image that we're going to use. And it's done. Let's just clear the screen and let's check again the images. So sudo docker images, and now we have two. Okay, now we have the OctoPrint image in our computer. Yeah, 965 megabytes, so close to 1 gigabyte. It's a really big image. Okay, so we've downloaded the OctoPrint image. So next we're going to run a Docker container based on this image so that we can start our OctoPrint instance. Okay, so I'll see you in a bit. Okay, so now it's time to run OctoPrint's Docker container. So for that, let's return to the Docker Hub page for our image, and here it is. Okay, and because this page also has the instructions, they usually do. Usage. We recommend you use Docker Compose to run OctoPrint via Docker and have included the recommended Docker Compose YAML file for your convenience. Okay, so this is exactly what we're going to do. Okay, we're going to use Docker Compose, which basically is a way for Docker to read the configuration for a given container from a file. It's this one, okay, and launch the container exactly with these specifications. Okay, so they provided the file for us, so let's get it. Here is the file in this GitHub repository. So this is the file. Let's click raw to get the raw copy of the file. Here it is. And now we can right click, save page as. And usually what I like to do is to go to my home directory and create an application folder. So in this case, it's OctoPrint. And inside here, I'm going to save the file. Okay, perfect. Okay, so now if we go over here to files, OctoPrint, here is the file. Okay, so we're going to look at it and maybe edit some of it if we need to. Okay, so this is the Docker Compose YAML file. Okay, I'm not going to go very deep in this. Okay, just a little bit. So basically this is telling Docker that we are going to run a service called OctoPrint based on the image OctoPrint/OctoPrint that we've just downloaded. The restart policy is restart always unless we stop it explicitly. Okay, so if the computer reboots or if the application crashes, the Docker will restart the container, okay, unless we tell it otherwise. Okay, this next section is the connectivity section, so it's the TCP ports. Okay, well, in this case they are TCP ports. On the left side of the colon, we have our host operating system ports. Okay, and on the right side of the colon we have our container ports. So in this case we're binding our Linux machines port 80 to the containers port 80. Okay, and this creates a bidirectional link. Okay, so anything we send to our port 80 will be routed to the containers port 80 and vice versa. Okay, so you can actually change this port on the left if you want. Okay, so if you want to have the OctoPrint's web interface in port 1234, you can do it. Okay, just don't change the port on the right, okay, because the port on the right is most likely perfectly aligned with the current configuration for OctoPrint inside the container. Okay, so if you change this, you will probably have problems in terms of connectivity. Okay, so change the one on the left, not the one on the right. Okay, but for me port 80 is fine. Okay, now devices. Everything here, so we're in YAML, we're using a YAML file. You can see the extension YML, and in YAML we use pound signs to indicate comments. So that's why this part is grayed out. Okay, so this is not visible to Docker Compose, but we need to make it visible because, so I'm going to uncomment this and this. We need to make our 3D printer visible inside the container. Okay, our 3D printer is currently connected to our host operating system, which is our Linux computer, but we need to pass it through inside the container where OctoPrint is. Okay, so that OctoPrint can interact with it, and this is how we do it. Okay, so in a similar fashion we're mapping an internal file to an external file, and in our case it's called USB 0. Okay, you can map it like that if you want. You just have to remind yourself that you have to use ACM 0 instead of USB 0. In the web interface, for me that is confusing, so I prefer to align the two. Okay, this is easier. Okay, this is not so error prone. Okay, so this is very similar to this kind of tunnel. Okay, so every time we write to this file, it is visible inside the container in this file and vice versa. Okay. Next line, video. This is for webcams. In this guide, we're not going to do that. I'm going to do a video in the near future on how to configure webcams in an existing OctoPrint instance, okay, but not here, so next. Okay, next we have volumes. Basically what the volume is storage space in our host operating system that maps to part of the file system of the container, in this case the /octoprint directory. Okay, down here we are telling it to either check that an OctoPrint volume exists, or if not, create a new one. And over here we're saying that the service OctoPrint will map the volume named OctoPrint to its internal /octoprint directory. Okay, so this is the container, this is the container directory, this is the name of this volume. Okay, basically what this does is that it preserves the contents of this directory in this volume, even if we delete the container. Okay, because usually without volumes, anything we do inside the container stays within that container, and that also means the file system. Okay, so when you delete a container, the entire file system is deleted as well, and all of the files and configurations that you've done, okay, plugins and printer configurations, etc., it's all deleted. Okay, this way with a volume you can preserve those configurations inside the volume even if you delete the container. Okay, this is very useful, for example, when you are upgrading your OctoPrint version. Okay, because you can just delete your current OctoPrint container, get the new image that has the new OctoPrint version, create a new container with that version, okay, and then point that container to the same volume, and he will recover the old configurations. Okay, admitting that both OctoPrint versions are compatible in terms of configurations. Okay, that has nothing to do with Docker, that is just how any application works. Okay, so that is volumes. Next, this environment variable is for a webcam scenario, so we're not going to talk about it. And yeah, and finally this is to, I believe, to be able to edit stuff in the command line, but we're using the editor, so it's fine. So we're done. So basically everything we did was to uncomment this devices line and then uncomment the 3D printer line so that it is visible inside the container and OctoPrint can talk to it. Perfect. Let's save it. Okay. And now let's launch our container based on this configuration. So let's open our terminal. Let's navigate to our OctoPrint directory and let's ls to see the file. Okay, so it's docker-compose.yml. Okay, YAML. Now, how do we launch a container based on the configuration stored in this file? Okay, we use Docker Compose for that. So remember, Docker is an administrative command, so use sudo docker, and now we'll use compose. Okay, when you are using compose in this manner, so as an attribute to the Docker command, you are using Docker Compose version 2. The previous version used an hyphen, so it was a specific command, docker-compose, but they've unified it. They've unified it into another attribute of the Docker command. So sudo docker space compose up, which means lift up a new container, please, or an existing container, because we might already have one. In this case, we don't. And I want to run this in daemon mode, meaning I want to run this in the background, okay, as a service. Enter. Now the password. and done. Okay, so now how do we check that the OctoPrint container is running? We can use sudo docker ps, which will list all of the running containers. And just let me maximize this, and here we are. So we have a container with this internal ID based on the image OctoPrint/OctoPrint. It's running the /init command. This is the internal command inside the OctoPrint container to spin up OctoPrint. Okay, it was created 16 seconds ago. It is running 15 seconds for 15 seconds. Here is the mapping of the TCP port, so all interfaces port 80 in our container are mapped to the port 80 on our host machine, and the name of the container is OctoPrint-OctoPrint1. Okay, so this name was created by Docker Compose. Okay, so it appears to be running. So how do we access it? We need to open our web browser, okay, and we need our IP address. I can go to this network thingy over here, wired settings. Of course, you can also use command line applications like ifconfig or something like that, but I'm a GUI guy myself, so here we are, 192.168.52.130. okay, so this is our IP address that is valid across my local area network. Okay, so any device connected to to this network can use the same IP to access the OctoPrint web interface, okay, by inputting this address. So http://192.168.52.130:80. Usually this is to indicate that we want to connect to port 80. In this case, port 80 is the default port for the HTTP protocol, so we don't need to explicitly input it. Enter, and here we go. We have the OctoPrint web interface up and running, so this step is complete, and next step we're going to configure it. Okay, so I'll see you soon. Okay, and we're back, and we're going to configure OctoPrint. So we're here in the setup wizard, and next, I don't have a backup to restore, so next, access control. Okay, so this is to create an administrator account for OctoPrint. So username, password, you input what makes most sense for you. Okay, create account. I don't want to save anything, and we are logged in as well. So next, connectivity check. Okay, configure the connectivity check. So OctoPrint every other 15 minutes, or recurrently every 15 minutes, he does this check, which includes trying to reach an external IP address, external from our local area network. In this case, is this IP address and port. So let's test it. Okay, it's reachable. Perfect. It's green. And the second test is DNS resolution, DNS name resolution. So we're going to use octoprint.org to try and resolve this name to an IP address. So let's test it. Perfect. Name can be resolved. So both this one and this one, both tests are correct. So connectivity check passed. And we now have the option to enable or disable this recurring connectivity check every 15 minutes. Personally, I like to keep it enabled because I like to be warned when OctoPrint loses internet connectivity. Next. Configure anonymous usage tracking. Okay, personally, I don't like this stuff, so I'm going to disable it because I don't know exactly what kind of information is being tracked, who is tracking, and what are they going to do with it. So given the option, I like to disable it, but if you want to enable it, be my guest and click here. Next. Okay, configure plugin blacklist processing. Okay, I want this enabled because for me in this particular case any kind of security is better than no security at all. And if someone is taking the trouble to create a blacklist of like malicious plugins, I want to benefit from that information. Next. Okay, now we need to set up our printer profile. Okay, so this is the part that is specific to your printer. Mine is Sovol SV06. I'll copy this to the model as well. Next, print bed and build volume. By the way, all of these configurations you can get them either from your manufacturer manual, from your user manual, for your printer user manual, or from your slicing application such as CUDA or Prusa Slicer. Okay, without these configurations you cannot print, so I guarantee you if you're printing, they're there and you can copy them over to here. Okay, so form factor rectangular, correct. Origin, so my XY00 coordinate is on the lower left side of the bed, correct. I have a heated bed, correct. I do not have a heated chamber, correct. So the kind of chamber that involves your printer, like using acrylic and or other kind of material that acts like a dome around your printer and allows you to, like for instance, maintain constant temperatures when you're printing, or stops dangerous and toxic gases from coming out, okay, when you're printing some materials like ABS, for example. Okay, I don't have it, so for me it's off. Please define the print volume. Okay, so X and Y is 220 millimeters and 250 for the height. Finally, custom bounding box. I don't want this, so this is when you want your print head to go outside of this specified volume. Okay, I don't want it to go outside of it, so for me it's a pass. Axis. Okay, so this is the feed rate, okay, for each axis. Okay, so X and Y are 500 millimeters per minute in my case. The Z axis is 10 and the extruder is 30. Finally, hot end and extruder. I'm using a nozzle diameter of 0.4 millimeters. That is correct. I only have one extruder in my 3D printer. That is correct. And the default extrusion length is 5 millimeters. That is correct. Next, server commands, just leave it as is. Okay, they are good to go as they are. Next, all done, finish, and here we go. Here is our little octopus. So perfect. OctoPrint is configured. I'll be right back for our last step, which is to test it. Okay, I'll see you in a bit. Okay, we're back for our last step in this guide, which is to test our OctoPrint instance. Okay, so on the top left corner here we have this connection zone. Okay, where we need to define the serial port. We already know it's /dev/tty USB 0, but you can leave it at auto. You can also leave at auto the baud rate, which is usually 115/200. Okay, you can leave both of them in auto. The printer profile is Sovol SV06 in my case, so this is the printer profile we've just created in the last step. You can ask OctoPrint to save the connection settings and to auto connect on server startup if you want. Okay, let's press connect and we're connected. Okay, so if we open the connection, we have the serial port, the /dev/tty USB 0, and the baud rate 115/200. Perfect. Okay, over here we're already seeing current temperatures for the print head and for the bed. Okay, And over here in the terminal, we can see that we are regularly receiving information from our printer. Okay, so this information is what allows OctoPrint then to draw these graphs and stuff. So we have, for instance, this line here. The T is the print head and the B is the bed. Okay, so in this instance the print head was 26 degrees and the bed was 33. And we also have these lines over here that are reporting the X, Y, Z and extruder positions, okay, from our print head. Okay, so let's try and heat the bed up just to send the command to the printer and see if it reacts. And yep, it's working. So over here we have the purple line, which is the target temperature, which in this case is 60 degrees. Here it is. And then we have the blue line that indicates the actual bed temperature. So it is currently rising. Okay, you can see it down here as well. 39, 39.7, 40. Okay, so it's currently rising, and it will rise until it reaches the target temperature of 60. So it's working perfectly. So let's switch off the bed. And so the purple line went down to 0 because our target temperature, our current target temperature is 0. And now the blue line will hit a plateau. It will start rising and then it will go down again to the ambient temperature. And as you can see, it is already going down. 43, 42.9. Yep, 42.8. Okay, it's already going down. Okay, so everything is working perfectly. One last test before we go, one final test. Let's restart our computer to make sure that OctoPrint is restarted automatically by Docker as we intended. Okay, so let's do that and we'll be right back. Okay, and we're back. We've just restarted our Linux machine, so let's check if Docker restarted the container. So let's do sudo docker ps, my password. Yep, it's running. So it was created 20 minutes ago and it's up for 40 seconds. Okay, so since this restart. Okay, so this means that we can open our web browser and navigate to the address that we had earlier to see our OctoPrint dashboard. Perfect. And now if we click connect, perfect. And now, yep, we are already receiving temperatures. Okay, and as you can see, the bed is still dropping temperature, so it's still cooling off. 39.2, 39.1, 39. Yep, it's going down all right. And here in the terminal, we're still receiving periodic updates, so everything is working perfectly. That's it for this guide. It's done. And that's it. I hope this was useful to you. Please leave your feedback and share your ideas and opinions in the comments. If you want to stay up to date with the next videos, you can subscribe to the channel and click on the like button. Thank you, and I'll see you next time.